Hi, this is Sam Lindsay from the Simulia Alliances team here in Providence. Today I have on the phone with me Nor-Tech and Intel, who are two of our hardware partners. We are going to be talking to you today on how to speed up your Abacus simulation on a cluster. And we're going to show you how you can learn about this on simulationclusters.com. So simulationclusters.com is a tool that's designed to illustrate cost and time savings when running your Abacus simulation on a cluster instead of an individual workstation. We've had this site around for a few years, but we just relaunched it in April of 2015 with a new cluster that's provided by Nor-Tech. And this Nor-Tech cluster is powered by the latest Intel processors. Before I get into more of what simulationclusters.com can do for you, I'd like to introduce Nor-Tech and let them go over what they do, who they are, and how they can help you out. So with that, I'd like to introduce Dominic Danager from Nor-Tech.
Who is Nor-Tech? Nor-Tech is a system integrator, HPC system integrator. We are located in Burnsville, Minnesota, which is a suburb of the Minneapolis-St. Paul area. Nor-Tech has been in business nearly 20 years and started out with the manufacture of PCs and servers and evolved that into a significant business in HPC over the years here. We are located in a 60,000 square foot facility that houses production, sales, support, engineering, and warehousing all under one roof in Burnsville, Minnesota. We are partnered with many different companies, including Intel, Supermicro, Dell, HP, and Lenovo on the hardware side, and various software vendors, including Microsoft, Red Hat, and many open source Linux solutions, as well as CAE software vendors, including Simulia Dassault. We have a deep experience in HPC integration, and over that time we've evolved into using a lot of different commercial and open source software packages, including CentOS, ROX, Red Hat, Bright Cluster Manager, SUSE, Adaptive, and Windows Server. We have found interest in some of the commercial space here for Windows HPC server, and in fact I served on the Microsoft HPC Advisory Board for 5 years when Microsoft was first entering the HPC market. We use hardware from a wide variety of vendors, but in the CPU space, that's pretty much evolved into Intel leading the race these days in HPC. CPU-wise, they also have introduced a product here few years back here called the Xeon Phi, with some new additions coming up shortly here that will be quite interesting to the HPC space. We also have done quite a bit of GPU cluster computing, with one of our largest installations being something we put together about 2.5 years ago for Syracuse University with over 88,000 GPU cores. One of the things that we developed here within the last 12 months or so is a demonstration cluster that we have partnered with Intel and Dassault Simulia to allow customers, particularly a lot of commercial customers might be interested in this rather, where it allows them to run their jobs on a test basis on this demonstration cluster, and helps them develop return on investment data to present to their management so that they can do higher resolution simulation, turn more jobs per day, and get their product to market sooner. This demonstration cluster comprised of 4 nodes, 96 compute cores, and the latest Intel Xeon technology available. One of the nodes is a fat node, is what we call it. It has 36 processor cores and Xeon Phi capability, and that can be exchanged out for GPUs on an as-needed basis, if that's desirable for testing. InfiniBand is a fabric that we use, the network fabric. That is frequently desirable because of the nature of these jobs being very chatty, especially for Abacus, and it generally provides a good performance enhancement. We also, for certain jobs, and it's determined by the specific customer needs and their job needs, will have the ability and do have the ability to use Intel solid-state drives for caching in the compute nodes. That can be very advantageous if the customer's job has large data files, and it makes a lot of sense sometimes to cache that out locally in the compute node and on solid-state drives. We've had many customers where we take these solid-state drives and put them in a RAID 0 array, and it gives them the advantage of the bandwidth of maybe 3 SSDs or 4 or 5 in some cases. And we've had customers express interest also in some of the newer technologies of solid-state drives like NVMe, which can give you probably 10 times the bandwidth capabilities of the standard SSD or even SSD RAID 0 arrays. NorTech has developed, as I stated earlier, a lot of expertise in HPC integration experience here. It's 15 years of experience now. We cut our teeth in the national labs and education market. We have a large portfolio, including well-known entities like the FAA, Boeing, Gulfstream, MIT, just to name a few. There's other educating entities like Cal State and MIT that are also customers of ours. So we have experience with integrating acceleration into HPC from the Xeon Phi and the GPUs, and we've done a lot of different storage options since all of these clusters are basically on a build-to-order basis. Those can range anywhere from simple NAS or direct storage right in the head node to all the way to the most complex, something like a parallel storage like Lustre is. We like to think of one of the things that makes our clusters unique is their appliance nature. By the time they leave here, we have the cluster set up so that it has the customer's DNS and IP address schemes, cluster name, and all that is already set for the customer environment. There is no changes need to be made about the only thing that needs to be connected is we need to connect to their network, obviously, their power, and sometimes we'll if they have a license server, we'll need to redirect from the temporary license server that we've used during the customer testing phase here at NorTech and switch it over to their corporate license server for some of the various CAE applications or whatever job applications they're running. One of the last things we do before our clusters leave the factory, and this happens after the customers have the opportunity to log in and test the cluster and hopefully develop their return on investment arguments, or maybe they've done that a long time prior to this in earlier testing. But it gives them the confidence that it's going to do the job for them. So once that phase is completed, though, and they have oftentimes created user accounts and put their data in and that kind of thing into the cluster. We'll do a bare metal backup of the storage. Typically, the head node is what is important to back up, and that is a disaster recovery thing. We've seen it come in very handy, particularly in clusters that we've supplied to education, where it's got students cutting their teeth on HPC, and it's amazing how innovative some of them can be in doing the wrong thing. So, but the idea is it gives you about a 30-minute recovery in the event of absolute disaster on the storage and the head node. So, versus 2 to 3 days or more sometimes to reconstruct a cluster installation by hand. So, that's been something that's a real gives customers warm and fuzzies and comfort level that they can stay in production.
Thanks, Dominic. Okay, now I'm going to show you quickly how you can submit a job and then just give you a little bit more information on what you can expect from simulationclusters.com. So first, you need to navigate to the website, www.simulationclusters.com, and on the upper right-hand corner, you'll see Virtual Test Drive, and that is where you want to click. That takes you to this page where you're going to have to complete some information, and you can see the terms and conditions on the right-hand side. Just be sure to click I accept, and then after you've filled out all the information, submit your request. Once you qualify, we will send you a confirmation email with instructions on accessing our secure file upload site to upload your Abacus simulation. Just as a quick note, you must be a current Abacus licensee in the U.S. to take advantage of this program. So once you submit your request and upload your Abacus simulation, the typical turnaround time is a couple of days to a week at the most. Once the simulation is completed, we create a report here at Simulia, and this is sent to you in a PDF file. This will show you the time data and a graph indicating the speed of the simulation on the cluster versus the speed of the simulation on your workstation. In addition, we're going to put you in touch with NorTech, who will discuss the report with you to help you further understand the benefits of moving from a workstation to a cluster. Also, you should note that there's no commitment required from you. This is all for your information and benefit only, and you can use it to help convince your executive team or your IT department that moving to a cluster would be a lot more beneficial for your company for a number of reasons. Also, you should know that the site is completely secure. Your data is sent to a Simulia employee only. It's not sent anywhere outside of our company, not to Intel or NorTech. As soon as we run your simulation and generate the report, we delete everything that you've sent, and we have no access to it after that. So this is an example of what the report would look like after we send you the results. This is an actual customer who used simulationclusters.com. So on the right-hand side here, you can see the comparison time. This is what the customer ran on their individual workstation. They ran on 6 cores and used 10 tokens. To run one job that they submitted to simulationclusters.com, it took about 19.5 hours. Once that was ran on our cluster, NorTech's cluster, with 64 cores and using 28 tokens, the job went from 19.5 hours to just under 2.5 hours. That's almost a 9-time increase in speed for that same exact job. So let's take that customer as an example, and we'll say that there's 4 of the same types of users that are running Abacus on 6 core workstations. Each of these users has 10 tokens that they use to run their jobs. They come in at 8 in the morning, they start up their jobs, and they submit them to their individual workstations. It goes throughout the day. Their computer is tied up. They can't run any other Abacus simulations while this is running. By the end of the day, they still haven't gotten their results. It's not until they come in the next morning that they get their results. So in 24 hours, they were able to run 4 jobs on those 4 workstations using a total of 40 tokens. Let's say they decide to run those jobs on a 64-core cluster. They come in at 8 in the morning, they queue up the jobs. The first job goes in the cluster using 28 tokens at 8 o'clock. At 10:15, that user gets results. After that, the next one goes in. A little over 2 hours later, the next user gets the result. 12:30, the third user, and around 4 o'clock, the fourth user gets their results. After that, they can queue up more jobs that they want to put in. So running on this one cluster in 24 hours, using less tokens, they're able to get about 11 jobs done in 24 hours. So as you can see, running their simulations on a cluster for this customer was a lot more beneficial. They were able to get a lot more done in a lot less time. So if you have any questions, feel free to reach out to me, Samantha.Lindsay, Lindsay, at 3ds.com, and I can put you in touch with the right folks to answer your questions. And that's it for our webinar. I hope that you enjoyed this and you found it useful, and I look forward to hearing from you.